Hello, everyone, and welcome back to Hack Summit. We sorry for the technical difficulties we're going to be bringing Dominic Williams on camera here for everyone to hear him. And I apologize for the delay there. I know that was a few minutes that everyone was waiting there, but we want to make sure that everything was set up technically correct for Dominic to educate you on Definity. So can everyone hear and see us now? Yes, everyone can see you. Fantastic. Great. So we're ready to go here. So I know we have a little bit of less time to go, but I want to make sure that we get the full vision and message for Definity out there. So let me first start by briefly introducing Dominic Williams, the CEO of Definity. Dominic is an incredible superstar in this industry. He's created something that's known as the Internet Computer, which is a huge vision for how blockchain can revolutionize our lives. He graduated from King's College in London with the equivalent of a summa cum laude style graduate degree. He created a massively multiplayer game with 3 million users called Fight My Monster, which became the fastest growing kids game in Europe. And so, Dominic, it's just a pleasure to have you here today. We know how busy you are and how large a team you're managing right now at Definity. So thanks for all of your time today.
Thank you for having me. It's an absolute pleasure to be here. And hello to everyone who can see me.
Yep, everyone can see you, and we love you. So basically, we've got a huge engineering audience here. Most of the folks in the audience are engineers. Some of them have built blockchain solutions already. Some of them are hungry and eager to learn about the options that they have to build on the blockchain going forward. I think we should start off by having you give a vision for Definity to the audience about what you've created and what can that inspire developers to create on the blockchain. So why don't you go ahead and run with that, Dominic?
Sure. So, the general vision is that, look, the internet was the first decentralized network, and it created an abstract connection primitive that allows any two computers to connect, irrespective of geography. And the internet, of course, is a public resource, and that's largely why people like using it. It's not a private network like AOL or CompuServe. It's something much more powerful. It's a globally shared public resource, and people don't need permission to connect to use this thing, and that means that you can be more confident building your infrastructure around it. We want the internet to perform additional roles in the same mode. So the Internet Computer aims to enable the internet itself to host software and data. And in order for that to happen, if you like, our general mission is to host the next generation of software systems. And in order for that to happen, obviously the Internet Computer has to have substantial speed, and it has to be able to scale out its capacity. There are also some other pieces to the equation. We also have to provide a developer stack that gives people a reason to build on top of it. Okay, so this is where you get into the realms of product market fit. We believe that it's possible to create a grand bargain, if you like, where, as compared with the traditional technology stack, the Internet Computer says, look, yeah, the hardware costs in terms of per processing cycle and per byte stored are going to be higher, and the reason is that the Internet Computer runs using advanced cryptography, and that's expensive. It also has to replicate data in order to guarantee availability and unstoppability and all of those other kind of features that people associate with blockchain. So the underlying hardware costs of the Internet Computer are going to be higher. But guess what? We can use the unique properties of the stack to reduce the total costs of ownership with respect to information technology. So first of all, if you look at the total cost of ownership, the majority of the cost is actually created by the complexity of the R&D involved, the complexity of the maintenance and administration. And we believe we can provide a very different kind of technology stack that is much simpler to build on, that reduces the total cost of ownership, even though the underlying hardware costs increase substantially. And so we're trying to perform this grand bargain, if you like, where in exchange for greater hardware costs, people get an environment that dramatically lowers the R&D cost, the maintenance and administration costs, and in addition to reducing their total cost of ownership, are able to develop systems on a hack-proof platform, which are much more secure, develop systems that are always available and much more reliable, develop systems that enable them to maintain the privacy of data where necessary, and are much more interoperable. So it's really a vision for a completely different way of building software systems. Now, those software systems can be, common cardinal, private software systems created by a company for some purpose. They can be more in the mode of, what we consider as a traditional blockchain application, a shared open platform that enables some industry to run a supply chain more efficiently, for example. It could be an internet service that's reinvented as an open source business. That means, you recreate an internet service using autonomous software with an inbuilt governance system. So like an open source business, or, in the future at some point, it could be a kind of decentralized financial application. So, it's very broadly applicable. And at the end of the day, the whole world runs on software. What we want to do is enable the internet, an open public resource, to provide the computation and hosting platform rather than, the traditional IT stack, which is, Amazon Web Services, Google Cloud, and all of those kind of pieces of software that you use on that infrastructure. So it's a completely fresh vision for how we should build software and host our data and so on.
That's fantastic. Thank you for that, Dominic. And so you decided to headquarters your organization in Zug, Switzerland, which might be a foreign place for a lot of folks in the audience who might not know about what's going on in the blockchain world. Why are you guys located in Zug, Switzerland?
There's a parent foundation, which is a not-for-profit. And, at the time when it was formed, the only people that had gone before, Ethereum was the only project that had gone, in the same vein. So, we're obviously looking for a model that had been proven successful previously to reduce our risk. And at the time, the Swiss Foundation model met our needs. And the reason that the sort of parent organization needs to be a not-for-profit is we're creating an open public network. And it's the internet computer, right? So just like the internet, you're not-for-profit supporting it, but it's fundamentally a protocol and an open public resource. So the internet computer is the same. And if in fact there was a company backing the internet computer, we feel it would be more like CompuServe or AOL, right? Or Amazon Web Services or something like that. And a key benefit of an open network is that it's independent. It provides that kind of guarantee to people building on top, and it's not pursuing its own commercial interests. It's just trying to build the best network possible for everybody as a public resource.
That's great. Very inspiring vision. And this is the magic of open source, everyone, is that not one company controls it. It's free for everyone to use, and it's a democratic system. And speaking of which, you have some really interesting governance innovations that you've created within Definity. Can you maybe enlighten our audience as to what those governance innovations are?
Yeah. So ultimately, Definity, just first of all, it is a blockchain computer, right? So it's a tamper-proof platform that provides the guarantees that blockchain usually provides. It's just that we use technologies to make it much faster and to allow it to scale out. Now, we believe that for a platform that can be widely adopted, governance is a kind of critical component. The challenge is if you have a foundation governing a decentralized network, the question is asked: is it really truly decentralized? It's obviously a single point of failure, and all kinds of politics arise. So the Definity network has an algorithmic governance system called the blockchain nervous system, and there are two sort of components to this. There's if you like, an on-chain component, a bunch, some privileged software that can reach into the internals of the network. And then you have these things called neurons, which are effectively sort of voting units that are run by individuals on client devices like smartphones and laptops. And this blockchain nervous system can modify the economics of the network. It can orchestrate upgrades of the network. It can freeze a miscreant system. So it's not a coder's law system. The blockchain nervous system is omnipotent. It can do what it likes. It can help organizations or people that have created some software system that's hosted by the internet computer that had a bug and went wrong in some way to fix that. It can actually reorganize the network structure. So of course, the DFINITY internet computer is sharded, and the blockchain nervous system can actually, for example, split a shard or reassign what we call a web canister from one shard to another to address the presence of hotspots and things like that. So we call the internet computer and the DFINITY network a fully adaptive network, because ultimately pretty much every aspect of it is subject to the blockchain nervous system.
Very interesting. And so let's say theoretically in the future, someone wants to make an improvement to DFINITY. Like there's an open source contributor out there that thinks, I have something valuable to contribute to DFINITY. How would that pull request get accepted? Like what is the process by which a decision is made for that?
So that's a good question. So in principle, anybody could submit a proposal to upgrade the protocol. Now, initially, those kind of proposals will involve the hashes of compiled software, right? So, a proposal would go in and say, we want to upgrade the network client or clients when we get to the point of end versioning, and these are the hashes, right? And people would compile down the software in the GitHub repo wherever it's located, make sure the hashes are correct, and so on and so forth. And, if the proposal was accepted, the system would orchestrate at some block height in the future the transition from a client with one software hash to a client with another software hash. Of course, in practice, the software hash might even refer to the installer, right? So at the moment, initially it'll be at quite a high level. Your question is interesting because, what would be really nice is if the source code itself was under the control of the blockchain nervous system, right? And it could actually control the adoption of specific pull requests and things like that. I think that should be possible at some point. The important thing for people to know about the blockchain nervous system is essentially every proposal has a topic. So topics, things like cryptography, economics, general governance, and so on. And the proposals are voted on by neurons, and a neuron is created by depositing definities, and very proximately the voting power of a neuron is proportional to the number of definitives deposited. You can't get these definitives back without dissolving the neuron. The longer you configure that dissolve window, the greater the voting power of the neuron and the greater the rewards it receives for voting. But since a lot of people, for example, don't have expertise in cryptography and don't want to invest the time or don't feel qualified to, judge whether some new curve needs to be adopted, you can configure your neurons to follow other neurons. So, for example, you might configure your neuron to follow neurons that are have been created by well-known cryptographers involved with the project. So like Jan Kamenisch, Timo Hanke, Manish Mohedi, and so on. And so you say, right, I want my neuron to follow these 5 other neurons on the topic of cryptography. If 3 of these other neurons vote to adopt a proposal, then vote to adopt 2. If 3 or more of those neurons vote to reject, then vote to reject 2. If neither of those things happen, by a timeout, then just vote to reject the proposal. And so, these neurons are set up, and a proposal comes into the blockchain nervous system, and essentially it sort of cascades to a decision. But because, for the most part, voting is automated, it's able to decide relatively quickly on proposals. So, it'd be interesting to see how that. I mean, at the moment, it's generally. I mean, obviously, in the first, there's only so many hours in the day. So, in the initial incarnation of the network, the proposals coming into the blockchain nervous system will be very high level. Upgrade to this new version of the client, modify these economic parameters, freeze this ISIS slave market, that kind of thing. Very high level. Most of the proposals will be high level, or a company or open source internet service, encounters some technical difficulties that are, best solved by the algorithmic administrator, if you like, and please upgrade the software system to the software system of this web canister to this because it's deadlocked currently, and that kind of thing. But it's a very interesting question. Could it be applied within a kind of source code control environment? I think it probably could. That'd be really cool.
Yeah, I agree with you. Very cool. And so you're credited as one of the original creators of Threshold Relay, and maybe you could kind of tell us what your vision is for Threshold Relay, how that applies to Definity, and maybe educate our technical audience on that.
Yeah. So actually, Threshold Relay was was probably the sort of foundational cornerstone technique that made the Definity project possible. So I spent a very long time studying traditional Byzantine fault-tolerant consensus protocols and trying to repurpose them for the decentralized network setting. So the decentralized network setting is rather different to the kind of setting that these traditional consensus protocols were designed for. Traditional consensus protocols are designed for, coordinating computers controlling a nuclear reactor or something like that, right? So, but in the decentralized network setting, often, have very large numbers of participants. So, in the case of the Definity network, we're optimizing for a case where we have 100 million computers backing the network, right? Because we're wanting to host the world's software. It's a pretty ambitious aim, and you need a lot of computational power to do that. So the question is, how can 100 million computers connected via some lovely P2P network rapidly agree and reach consensus on, for example, some central blockchain that's shared by everyone that acts as a sort of single coordinating record of agreement and logical clock? How's that possible? Well, traditional consensus protocols don't scale very well. So, this is why, if you look at the protocols that rely on these schemes, they often involve some small number of servers with special, privileges. So, like in EOS, we've got 21 block producers. Ripple, I think at one stage is just running off 5 servers out of their broom cupboards and so on. So, that's not the Definity vision. The Definity vision is that there aren't no nodes in the network have any kind of special role. It's truly decentralized and extremely robust. So in that sense, none of the existing networks, meet our requirements. Bitcoin and Ethereum obviously, backed by these mining pools, and they act as kind of individual players and so on. So, we want to have, tens of millions of computers in our network that are all playing an equal role in consensus. Anyways, how do you get there? So I found this way of creating what's known as a random beacon in a decentralized network of unlimited size in a way that's completely unmanipulable, right? According to the maths involved, just completely unmanipulable and unstoppable, and also proceeds with high performance without running a consensus protocol by leaning on the power of cryptography itself. So I use something called a unique deterministic threshold signature scheme. It's the BLS scheme that was invented at Stanford. So one of the inventors is a guy called Dan Bonnet, and that's the B in BLS. Another one's a guy called, I met Dan Bonnet in early 2015, and he provides some assistance. Another, the L is a guy called Ben Lin, and he works here at DFINITY. Anyways, I realized that you could kind of chain these threshold signatures, and you've got fault tolerance from the threshold signatures because you only needed like a small, a fraction of the group of these groups to participate in creating a signature. So you got fault tolerance, but you could chain these signatures to produce a random beacon, a sequence of random numbers, and it was unmanipulable because, or is unmanipulable because the interesting property of BLS is, given some message that needs to be signed, given the public key of the group, it doesn't matter which subset of the group participate in creating a signature on that message. The message is always the same. There's only one possible, the signature is always the same. There's only one, given the public key of the group, given the input message, there's only one possible output signature, right? Now, of course, the output signature must be a random number, otherwise it'd be predictable and the scheme wouldn't be secure, right? So anyhow, you start off with a genesis, one such group signing, for example, the genesis hash or something like that, produces the signature. That signature is a random number. It selects the next group, right? And that next group, which has a public key, signs the previous signature. There's only one possible valid signature, right? And this new random number selects the next group. So it's unpredictable because you need a threshold of the next group to collaborate to produce the next signature, right? It's fault tolerant because you only need a subset of a group to be online and to participate to create the signature. It's unmanipulable because there's only one possible signature and so on. So the incredible thing is you get this incredible resistance to faults. So for example, if you have a network of 10,000 computers, 3,000 of those computers are faulty, controlled by some malicious adversary, and the group size is 400, the chance that a randomly selected group will fail is actually 10 to the minus 17. So it's like heat death of the universe time. It's just not going to happen. Meanwhile, the groups are able to produce the next random number by through a total broadcast over the P2P network of only 22 kilobytes. So, you can have a huge network of tens of millions of computers, and it produces each subsequent random number by broadcasting only 22 kilobytes across the network. And of course, in a highly connected random graph, that will happen pretty quickly. So, yeah, imagine that. So we've got test networks with hundreds of computers distributed around the internet, and if you wanted to, you could run a random beacon over the public internet that produced a new number, every sort of quarter of a second or something. It's insanely fast, insanely efficient, and the beautiful thing is, you're producing this sequence of random numbers that everybody in the network can agree upon, but you're doing this without running a consensus protocol. The whole problem with performance is consensus protocols, right? Traditional Byzantine fault-tolerant consensus protocols just don't scale. And yet here we can create a sequence of random numbers that everybody agrees on. It's completely unmanipulable by leaning on advanced cryptography with huge efficiency and speed, and with incredible fault tolerance. So just basically unstoppable. Now I realized, once I saw this in early 2015, okay, if I can produce a sequence of random numbers in this way, and I think actually it's the first time in human history we've ever had a random beacon where there isn't some central party who can somehow manipulate it or see into the future, right, and somehow predict what future values might be. It's the first time in human history we've had that. So if we had this, if the decentralized network can generate this sequence of random numbers, well, guess what? We can use those random numbers to drive other protocols that bring the network to agreement. And then we had, this thing. Lots of different protocols actually were devised that the random beacon could drive. But the one we're using in the current network is a thing called probabilistic slot consensus, which you could argue in some ways is inspired by Nakamoto consensus, although it's very different, has very different properties. And that's like it looks in many ways like like a sort of traditional blockchain protocol. It uses some additional things. For example, we're also using those same groups that are producing the random numbers are also notarizing blocks that are produced, which helps us produce much faster finality. So anyways, in our current test network, we're producing finality in under 2 seconds on the public internet. So this is vastly, vastly faster than anything around today. I mean, vastly faster than Bitcoin. So Bitcoin is in expectation an hour, but there's a Poisson distribution. It can take less or longer. Sometimes Bitcoin takes a few hours to reach total finality. But anyways, in expectation, it's an hour. It's 3,600 seconds. Ethereum is about 15 seconds, 37 blocks, something like that. It works about 10 minutes, 600 seconds. Meanwhile, Definity, with far greater decentralization, with far higher security, is reaching finality in normal optimal operation in a couple of seconds. So it's a huge, enormous speed up that's been achieved, and that's obviously only part of the work we do. But it's certainly true that threshold relay and probabilistic slot consensus are like sort of cornerstone techniques that made the internet computer possible. But obviously, there's many other components to it. We're using WebAssembly, for example, as a virtual machine, and there's a whole lot of work ongoing in that respect. We've got this guy, Andreas Rosberg, who in fact was the co-designer of WebAssembly, and previously was an architect of V8. Then Andreas still leads the WebAssembly standards process. He's a Definity staff engineer. So obviously, WebAssembly is a critical part of our overall strategy. When you dig into the Definity stack, you find that in order for us to get to actually deliver that super fast finality, we need a P2P the P2P networking layer to provide various special properties. So we have our own P2P system, and so it's a really very involved project. There's a very big team of very serious engineers and researchers beavering away on many different components. And it's probably in terms of complexity and design and sort of if you put the test network live, not only would it outperform existing blockchains, there's a lot more depth in the actual technical stack involved behind it, making it work. But we have a slightly different set of objectives. That we're not kind of trying to compete in the blockchain space. We're really trying to compete with the the legacy traditional technology stack. So we've got some way to go before we're ready to release the thing, I think.
That's an incredible explanation. Thank you for that, Dominic. So, in classic computer science, the way that I was educated and the way that a lot of other developers was educated is that there's always trade-offs, right? If you maximize for one outcome, another outcome may suffer a little bit. So in your architecture of Definity, what are the trade-offs in your mind? What are the use cases that are appropriate? What are not appropriate? What are some potential downsides of the approach that people should be aware of that kind of make up for the upsides? Any thoughts on any of that?
Well, I think one of the problems with the space is it's very nuanced. Look, you mentioned, it's a long time ago. It reminds me of my age, but I'm pretty good at computer science. I got some prizes and so on at the graduate level and so on. I've been a long-standing distributed computing enthusiast, and built my own distributed systems that have hosted millions of users and things like that. So, but nonetheless, when after I sort of got into decentralization in 2013. I was kind of primed for it. As I say, in 1999, I saw this guy Wade Dye's B-Money paper, but I really got into it properly in 2013. I already had some experience in distributed computing and cryptography. In 2014, I started studying traditional Byzantine fault-tolerant consensus protocols, and I was studying full time and very seriously. It took me 3 months of studying the bloody things before I really felt that I grokked that particular branch of computer science. And it probably took me, 4, 5, 6 months before I could start combining these protocols and schemes to create my own new protocols and schemes. And that was, having this background in computer science and being willing to dedicate this huge amount of time to studying them. So it's really difficult, I think. It is advanced computer science, and it's tough to just apply sort of general rules. And what I would say is, even here at Definity, I mean, obviously I do a lot on the business side too, but I struggle to keep up, right? Because it's a big, we've got a big team of researchers, and so I have to look at the kind of high level, right? Cryptographer will say, well, these are the properties of this scheme, right? And I can't like dive into it. Individual components are becoming very complex, and there are right now outside this room, there are teams meeting all through this research center, and other research centers are going up, and so it's very difficult, I think, to just simplify it. So Definity, like a technology like the internet computer, Definity technology is way more advanced, for example, than the original Bitcoin technology,
Mm-hmm.
and that's just going to continue. There's so many researchers coming into the space, bringing their own pieces. But what I would say, if I had to be drawn on that, is I think that my prediction is everybody will end up using some variation of threshold relay, right? The approach is superior, vastly superior to. I mean, the fact is that you can create this sequence of random numbers, which is completely unmanipulable, in a network of any size, pretty much, with very low overhead, without running a consensus protocol. Why would you not do that, and why would you not use these random numbers to drive other protocols? So we're in a. I think the difficulty is that I know of lots of projects that are already working on their own variations of threshold relay, and even applying cryptography libraries that we put out there on GitHub. But we live in a very competitive space where anyone can come up with some novel consensus protocol, and on the back of that novel consensus protocol can raise money from venture capitalists to run an ICO. And so everyone's very keen on presenting this or that scheme because they get a huge amount of money from doing so. On practical analysis, do some of these schemes stack up? I don't really think so. Competitively, with respect to things like speed, the ones I've seen really, perform much worse and have worse fault tolerance, worse security properties. So I think in the end, threshold relay is going to become a sort of dominant technique. People will use threshold relay to generate a sequence of random numbers in this way, and then people will develop novel protocols that are driven by it. That would be my guess. I just think that the approach is too good not to use. Right? There's no other way of doing this, unless someone wants to invent a entirely new form of cryptography, which is possible. Maybe someone will invent a completely new form of cryptography, or find some other way of applying cryptography to create a random beacon with similar, fault resistance and performance. And maybe that would obviously be better, right, than the scheme that we have. But I think that's the best way to go. Generate your random numbers in a way that can't be stopped or manipulated, and then use those random numbers to drive other protocols.
One of the other things that you've been credited with in the innovation area has been the idea of validation towers and puzzle towers. Could you maybe get our audience up to speed about what those are and what they can learn from that?
Yeah, so to be clear, I mean, we may not actually use validation towers and validation trees. However, they're a very interesting technique. Now, the reason Definity may not use them is they introduce a bit of latency. So, if you have like cross-shard communications in the Definity network, you'd introduce, like 9-10 seconds of latency for cross-shard communication. So there are some trade-offs we may prefer, right? But nonetheless, validation towers and validation trees, a very powerful technique. And so to explain the challenge, if you think about a cryptocurrency like Bitcoin or Ethereum, there are several pieces to it, right? One is how you get everybody to agree on the current state. Another piece is how do you make sure that everyone's agreeing on on valid, transactions or computations, right? So there's a validation component to this. Now, the way Ethereum and Bitcoin work, it's everyone runs the same transactions or the same computations, and the majority reaches consensus, right, on what it thinks it should be, right? Now the problem with that, of course, is that it doesn't scale. So today on Ethereum, everybody runs the same computations. I don't know how many full nodes there are out there. Let's say there are 20,000 full nodes. You submit a computation to the Ethereum network, 20,000 full nodes are going to perform the same computation. Now that's clearly very, very expensive, and it's actually prohibitively expensive. It means that there's so much replication going on. You couldn't possibly use a network designed like that in the way that we imagine the internet computer being used, right? So the challenge is, how can we have a much smaller number of computers in the network, replicas effectively, perform a computation, right? Or process a transaction, whatever it may be, without reducing the security, right? Without undermining the security. Now, the reason that sharding is so difficult is, if you just partition your network, let's say here's a shard of 20 computers or something. Well, it's clearly possible that those 20 computers, because there's so few of them, might be taken over by the adversary or some, notional malicious party, right? And that malicious party could then make that shard of 20 computers, for example, manufacture ether, right? And so you get this kind of weakest, the chain is only as strong as its weakest link problem. Once you partition the network, the partitions are much weaker, and if they become, hostage to the adversary, he controls them. He can export bad tokens to the rest of the network, and the whole thing falls apart. But the whole thing, because a decentralized network mediates participation using its, core token, right? If somebody becomes broken, right? So that's a big challenge. So validation towers provide a way of placing of processing the output from a shard using random numbers that allows you to get the same kind of security from that shard with a much smaller number of randomly selected nodes validating the state transitions that that they're performing. So if you like, the original Definity architecture was a sort of three-layer architecture. On the top level, you have threshold relay and a PSC chain, a sort of master chain that everyone's connected to. At the bottom level, you have the shards, which are responsible for storing partitions of the data and processing transactions that act on them. But in the middle, you have this validation layer, and it comprises validation towers that are arranged in a thing called a validation tree, which is performing a similar kind of role that Merkle trees do, but in a sort of distributed setting. And it makes it possible to ensure that a small shard of say 20 nodes, or even 8 nodes, or just one node, right, can't cheat and do something bad, like make some illegal state transition. But it's the cost of a little bit of latency. I mean, Definity may choose a slightly different mechanism, but certainly it's a very useful technique, and I'm sure a lot of networks out there could apply validation towers and validation trees very, very usefully.
Thank you, Dominic. And one last question from me before we go to the audience. So one of the things I think is fascinating about Definity is the idea of avoiding hard forks in the code base. And I've noticed that, with Ethereum, you've got like Ethereum Classic, and with Bitcoin, you've got Bitcoin Cash. Why do these hard forks happen, and how does Definity plan to avoid those hard forks?
Yeah, so I think that first of all, once you move to a network of massive scale with potentially thousands or millions of shards, right, forking becomes, for all practical purposes, impossible, right? Forking as we know it today is only possible because you just have a single chain, a single shard, if you like. So I mean, whenever you want to scale out a decentralized network, there'll always be a single master blockchain, which is this single shared record of consensus, and you have some kind of tree, like a Merkle tree, where the root hash is stored and for the whole network, right? But then you'll have shards that in the case of Definity will run their own threshold relay and PSC, and but the ultimate record of consensus is held in the master chain. Bitcoin and Ethereum at this stage only have a single master chain, right? So that makes it extremely easy to fork because the master chain is by design can be held on a single computer, right? So you can just make a bit of, you can just introduce a new client that changes the protocol slightly, and boom, you've got a fork. That's much harder if you have a massive scale network with lots of shards. I mean, the technical challenges involved with forking something like that would be absolutely enormous, right? Because you'd have to sort of coordinate all of these shards. Everyone would have to kind of fork together. So it's not clear to me how somebody would approach that problem. Assuming that you could get massive community buy-in to some kind of fork like that, you'd then have other challenges in the case of Definity because we're using threshold cryptography, and so the keys are distributed across, the private keys are distributed across multiple parties, but enable them to act as groups, in encoding threshold signatures and so on. So that would be another challenge. Another challenge, if we're using hardware enclaves, for example, is that the data on disk is actually encrypted, and it's kind of tied to the individual hardware. I know it's just a much more difficult thing to do, and that's so that's just I'm not sure how you'd actually fork a network like that practically, but the blockchain nervous system also coordinates protocol upgrades and so on. So hopefully people will be happier with decentralized, genuinely decentralized governance than they always are when it appears to be a small group of people in a foundation or a company making decisions.
Mm-hmm. Great. And then, sorry, one last question from me, because I'm dying to know about this. You have this concept of dynamic economics, the idea that the economics themselves can be malleable and can change over time. Walk us through your vision for that and how that might play out.
Yeah, so well, I mean, first of all, if we think about the Ethereum network today, just like Bitcoin, when the protocol was designed, it had a predetermined issuance schedule, right? The mining rewards are determined ahead of time by an algorithm. And what this has meant is that as the value of the tokens that can be earned by the mining rewards have increased, the amount of energy being burned in the proof of work scheme has also increased to absolutely insane levels. And, look, I'm a huge fan of the decentralization industry. I'm dedicating my life to it. But we have to be realistic that, Bitcoin and Ethereum represent environmental catastrophes because of that aspect of their design, right? More practically, you probably look, it's probably been running the Ethereum network over the last years probably cost billions of dollars, and this is for a network that can process a handful of transactions a second. This doesn't make any sense. It would have been much better to have, funded a moderate a network which didn't just burn all this energy out, right? And so I think that Definity, so we did more. It's obviously not a proof of work network in the first place, but we don't want just to create some competition where everybody is joining, miners are just joining more and more computers, when there isn't the need for the capacity just because they want to get the mining rewards. And we don't want to end up with like 1 million computers connected to the DFINITY network when we've only got like 10,000 users or something, right? So, because ultimately, if we're just diluting, just issuing definities according to some fixed schedule, to fund capacity that we don't need, I mean, that is depleting resources that could potentially be used later on, right? When we do need the resources. So anyway, the point is, DFINITY doesn't have some kind of fixed issuance schedule. The blockchain nervous system controls the economics of the network, and the blockchain nervous system's objective, given the way the incentives are set up, is to increase the value of definities. Now, it will decide on the best economic strategy at the time, and it might be that the blockchain nervous system decides that when people pay definities to install software and run computations and store data, that some of them are paid to miners and some of them are burned, reducing the supply of definities. It might be that the blockchain nervous system decides that in the early days of the network, it should subsidize sufficient scale so that people get some good guarantees about the capacity of the network in the early days when they're building on top of it. But those decisions will be subject to the blockchain nervous system. Now, what does that mean in practice? It means that we're going to have economics quants that PhDs effectively that spend a lot of time studying the economics of the network, and they will submit proposals to the blockchain nervous system, probably which contain links to their papers describing their, why they want to adjust the economic parameters in some way or another. And I suspect in the end that's how the economics will be determined.
Very nice. Thank you, Dominic. We're going to jump to the audience questions here. I'm just going to skip around a little bit here. So Tim asks a very thoughtful question here, which I'm going to just paraphrase it because it's a pretty deep question. What essentially Tim is asking here is that the blockchain nervous system that you're proposing allows for human collaboration and human intervention with DFINITY, and that you're actually putting your stake at risk, right? And that's the basis for your voice in the network. How do we prevent a plutocracy, which is where the wealthy are governing the system, from happening, where they can just basically and not make it fair for everyone?
Well, I mean, it's a good question, and I think no one's really solved questions relating to economies of scale of capital, right? So the first thing is, the blockchain nervous system per DFINITY provides a level playing field. So, if you create a neuron with 100 DFINITIes, well, that's obviously got 100 times the earning potential of a neuron created using a single DFINITY, but it is proportional. You don't, the voting power and the rewards of that neuron created with 100 DFINITIes are 100 times greater than the neuron created with one DFINITY, but it is proportional. So it is a level playing field. So if there is some party that is very wealthy and has a large number of tokens that they put at stake, it's true they're going to have a proportionally greater influence. But with respect, for example, to the rewards, if they were able to push through some economics that provided greater rewards to neurons for voting, well, those rewards would also be distributed proportionally. They wouldn't be, disproportionately able to, advantage themselves. There's another aspect to this too, which is, the blockchain nervous system makes decisions ultimately with the aim of increasing the value of DFINITIes. So, it's the case that even if you have an outsized influence, your incentives are really the same as everyone else's. In fact, arguably, you care even more about the success of the network because you've got more at stake, right? So the only way the rewards vary, it relates to how long you are willing to commit your definitives to the neuron for. So, I think in the original articles going back, was it like a year or 2 years or something about the blockchain nervous system? It was going to be like 3 months. Like, hey, you'd create a neuron by locking your definitives up for 3 months, right? And not locking them up for 3 months, sorry. You create a neuron by depositing these definitives. And you could only get the definitives back by dissolving the neuron, which would take 3 months. So in the scheme we're looking at now, it's a little bit different. When you deposit your definitives, obviously you specify how long you're depositing them for, and it's variable. So, you could say I'm depositing my definitives with a 4-year lockup, right? And the voting power of your neuron and the rewards you receive increase with the lockup commitment. Now, once you've done that, once you've created this neuron with say a 4-year lockup, every day that passes, the lockup decreases. And the lockup period can only decrease through the passage of time, but at any moment you can increase the, say, right, I want it to be, say it's the lockup period is decreased to 3.5 years. You can say, well, I want maximum voting power and rewards, and you could just push it back up to 4 years again. So we're trying to incentivize long-term thinking.
That makes a lot of sense, because then you're incentivizing folks to really care about the network in the long run, and to not optimize for the short term. I mean, you look at the stock exchange we have right now in the NASDAQ and then NYSE, and how CEOs are being incentivized to fire their employees and to pump and dump the stock price and things like that. This type of scheme seems like it could prevent that.
Yeah, I mean, totally. In the most extreme case, it could be a security risk. I mean, imagine there was no lockup at all. Imagine you could just deposit your definitives to create a neuron, and then you could, anytime you wanted, immediately dissolve the neuron and take the definitives out and send them to an exchange. It might be that some adversary decided to put a stupid proposal into the system that they knew somehow would devalue the network in the eyes of the markets, and they could sort of deposit a whole load of definitives into neurons, help push this stupid proposal through, and then try and quickly dissolve their neurons and get them out and sell them on the markets, and then short definitives, right? and try and make a whole lot of money that way. So, and then, if you've only got a 3-month lockup, well, markets are fickle, don't really understand what's going on. And, again, an investor could come in, could help push some proposal through that created some, short-term pump in the markets, which ultimately was going to be very damaging. But, they could, strategize, quickly dissolve their neurons, sell them on the markets at this big price, and everyone else, all the long-term holders, would be harmed. So, you're right. That's why we feel that the longer the definitives are locked up in a neuron, i.e., the longer it takes you to dissolve a neuron and get your definitives back, the greater the rewards that the system should provide that neuron for voting, and the greater the voting power of the neuron too.
Great, very helpful. We're going to do just a couple rapid fire questions here, so feel free to just quickly answer these. We're running a little bit low on time here. What is Definity's plan on partnerships? Are you planning on partnering with other organizations like Ethereum and Tezos and Bitcoin, or will it be a separate ecosystem from those ecosystems?
So, it's a good question. I mean, look, I'll be frank. For me personally, we're very friendly towards Ethereum. There wouldn't have been a Definity without an Ethereum. We believe that Definity and Ethereum are essentially quite different things. And so, we will certainly look at, and we have already, pushed technology into the Ethereum space through some of the WASM work and things like that. So, we are generally sort of friendly-minded towards Ethereum and happy to share technology with them and things like that. that's just mainly to do with the history of Definity, I suppose, and also because we like the platform and the vision. Other than that, we do work behind the scenes with quite a lot of decentralized projects that are interested in, a high performance, more scalable platform and the programming model that we're developing. We're also working with some very big organizations that are interested, for example, in reinventing corporate IT. Definity isn't the corporate chain. I should just to say that, but we do work with these different sectors, and it's a slightly different model, I suppose. We're a little less open. We're a little less under the radar. Sorry, a little more under the radar. But anyone out there that's interested in working with Definity and wants to sort of get a heads up on where it's going and so on, or maybe get an early access to developer platforms, that kind of thing, should feel free to contact us.
That's great. And actually, on that note, we had a question from the audience. One last question we'll take here, which is, there's an entrepreneurial developer in the audience that noticed that Definity has offered some seed grants to peer-to-peer developers. And is that accurate to your knowledge? And does Definity anticipate providing seed grants to developers? And if so, how can developers in the audience apply and submit proposals to build applications on Definity?
Yeah, so we're very keen to. So there's sort of two bits to this. Like, Definity will sometimes fund kind of projects, particularly sort of more academic projects, even though there may not be any immediate short-term win for us, right? And there are a few projects that we direct funding to, not because we're necessarily looking for anything in return, just because we think they're important projects. So Scuttlebutt, right? If you've heard of that, as an example, we help fund Scuttlebutt just because we think it's an amazing project. We will also, fund. I think there's I don't know exactly because I don't run this, but I think there's a PhD program. So we fund some PhDs. We're generally open-minded. We'll fund all kinds of things. If the funding required is more substantial and people are wanting to build on top of Definity, for example, there's actually there's the venture fund everyone knows about, which is co-managed with Polychain, and that's just it's organizing itself now. We've just in the last couple of days hired a fund manager. So there's a venture fund we co-manage with Polychain. There's a venture fund for Asia, Wangshang are running, and there's a third fund in the works which I can't announce yet, which is has a very specific focus. So we are thinking about how we can help bring funding to people in the space, whether they're just working on some interesting little project that doesn't need much money, they just need a bit of support, whether they're PhD needing some funding to work on something that might be relevant to Definity or the space generally, through to people that need larger amounts of money that need to be able to show investors how they can make a return and perhaps directly benefit the ecosystem. So we are addressing the full spectrum. What I would say is that our bandwidth is crazily constrained. We're scaling the Definity organization. People are sort of constantly running between R&D meetings, hiring meetings, and in my case, dealing with outside parties too. And so don't give up. Feel free, just to keep trying to talk to us and recognize things can take a while. But we are doing our best to try and support the ecosystem and the community as best we can.
It's very admirable. I appreciate that you have this venture fund, because you're going to be helping to create another wave of innovation through that. And that's going to be helping the open source community. Great. And so one last question from me is, what's the timetable going forward? Any rough window for when you think the audience will be able to tap into Definity going forward?
Yeah, it's a really good question. So I mean, the first thing, just to put give the context. Yeah, Definity is a very, very ambitious project. It's not just a blockchain. right? So we're trying to create, we're not trying to compete with other blockchains. We're trying to create really a competitor to the existing technology stack. We want to create an open platform that hosts the next generation of software. So, it's a big challenge, right? Obviously we have to be able to scale the platform. It's a given. That's why it's called DFINITY. But we also need to be able to provide good performance. The cost of running software and hosting data has to be reasonable. Security obviously has to be fantastic. The environment that we provide people to build systems in has also to be kind of revolutionary, right? And we think we've got a formula. For example, we've already got an SDK and things like that, but for the first generation hypervisor and the second generation hypervisor will be quite different. It's a difficult question for us when we should launch. The problem is if we launch too early, we're going to end up supporting a user base that is built on, generation one of our technology. And, Ethereum, has that problem to some degree, right? It's not easy for Ethereum to develop their network and add new features, right? Because you've got this huge stack, built on top of it now. There are companies that have built, developer environments around the VM and so on. It's not easy to change.
It's like the more complexity you build out, the harder the maintenance is. And so you almost want to avoid that complexity by being conservative on your release schedule.
Yeah, exactly. So, we would like to launch with quite late in the day with something that we really feel also delivers enough components of the internet computer vision that people can say, wow, that's world changing. I can see how it's going to reach its objectives. And obviously, in our case, the objectives are pretty ambitious. So, we've got DFINITY test network, and we've got 2 languages in production now, third one underway, which compiles down to WebAssembly. We're wanting to. This is our vision. The Node platform, which I think is the most widely used programming platform around today, grew so fast because they kind of recycled JavaScript developers, right?
And JavaScript is sadly the #1 programming language out there because all the front-end developers can now build server-side applications because they can now embrace Node. Yeah. And as a practical businessman, I get that and I embrace that, even though I don't like JavaScript as a programming language. That is the reality that we live in.
So we want to fix this. So, WebAssembly is probably going to replace JavaScript, right? It's a much more powerful platform. And you can run things at native speed inside the browser. And any number of languages can compile down to WebAssembly. Our vision is that some of the languages will be feeding into the WebAssembly community can also be used to create back-end code that runs on the internet computer. We're trying to do this in such a way that there are no APIs involved whatsoever. You just have this eternal code, not eternal code, like eternal execution, right? So you don't need a database, you don't need a storage API, you don't need a file, right? You just write code with, if you like, infinite process memory that holds all of the data involved in its software abstractions, such that you can write your WebAssembly client code that runs inside the browser, and you can write the back-end logic, if you like, in the abstract, just in software, and not worry about life cycle or persisting data in a file or a database, because that software runs forever and those abstractions remain virtually in memory forever, kind of thing. That's the vision, that WebAssembly developers can just create the next generation of software systems, and that the entire legacy software stack can, to some extent be pushed on the scrap pile. So people weren't messing around with all these different components and firewalls and web servers and databases and all this kind of stuff anymore. They'll just be, writing the software that compiles to WebAssembly, both on the front end, in combination with a bit of JavaScript and HTML, obviously, and on the back end. But you know that distribution is abstracted away, and there's certainly no need for databases and files and things like that. You just write your logic in software, and this software can call into other software within a secure capability-based security system that prevents. We're trying to provide a framework that doesn't lead to the kind of security kind of issues that we've seen today. So I don't know how much is spoken about publicly, but it's an actor-based software model. So, software units speak to each other by passing messages. There isn't any kind of reentrancy risk, for example. Capability-based security is something else altogether. So in the Definity network, if you want to send a message to another actor, a message being a function call effectively, right? You need a reference to its function. So just things like that. There's a sort of whole new vision for an environment that can be used to create the software systems of tomorrow with much greater productivity, but also then inherently more secure, more reliable, more interoperable, and also the backend platform provides technology that enables you to protect the privacy of your data without the developer themselves having to create any cryptography.
That's awesome, Dominic. Thank you so much for the incredible vision you've outlined for us today for Definity. We're super inspired. Our audience learned a lot. I learned a lot. And I want to acknowledge you for helping the nonprofits today by being here. We're raising money for Women Who Code and other important nonprofits like the Electronic Frontier Foundation. If you learned something today, please click the donate button on the bottom of your screen. And we'll be right back with Antonio Salazar from the Keep Network, a privacy layer from Ethereum. You're going to learn in just a second. So thanks again, Dominic. Appreciate your time today.
Pleasure. Thank you for having me. It's been fun.